Hello everyone, my name is Rutuja Vijayarao Pimpadkar. My project title is Predicting Customer Dissatisfaction in Brazilian E-commerce Orders Using Machine Learning. My research question is, can we use machine learning algorithms to predict whether the customer would leave a negative review based on delivery performance indicators, payment attributes, product features, and other characteristics? This is useful because negative reviews can show problems in customer experience. If an e-commerce platform can predict dissatisfaction earlier, it may help improve service and reduce customer complaints. Dataset and target variable. For this project, I used the Brazilian e-commerce public dataset by Olis from Kaggle. The dataset contains order information, reviews, payments, products, customers, sellers, and location data. After cleaning and merging the files, I used 95,832 delivered orders. The target variable was created from the review scores. Reviews with scores 1 or 2 were labeled as negative reviews, and scores 3, 4, or 5 were labeled as not negative reviews. The negative reviews rate was 12.8%, so the dataset was imbalanced. Pre-processing and feature engineering. The original dataset had information spread across different CSV files, so I merged them into one order level dataset. I created important features such as delivery time, delivery delay, late delivery indicator, total price, freight value, number of items, number of sellers, payment value, payment installments, product details, and customer and seller location features. Missing numerical values were filled using the median, and missing categorical values were filled using the most frequent value. Categorical features were one-hot encoded. I did not use review comments or review timestamps because they could cause data leakage. Models and evaluation strategy. This was a binary classification problem, so I used a dummy classifier as a baseline and then compared 3 machine learning models: logistic regression, random forest, and gradient boosting. Logistic regression was a simple interpretable model. Random forest and gradient boosting were used because they can capture non-linear pattern in the data. The model were evaluated using accuracy, precision, recall, F1 score, ROC, AUC, and confusion matrix. Because negative reviews were the minority class, I focused mainly on the F1 score for negative reviews. Key finding. One of the strongest findings was the late delivery is strongly linked to negative reviews. For orders delivered on time or early, the negative reviews rate was only 9.3%, but for late deliveries, the negative review rate was increased to 54.1%. This shows that delivery punctuality is a major factor in customers' dissatisfaction. It also supports the idea that operational features can help predict negative customer experience. The best performing model was random forest. It achieved an overall accuracy of 0.89 for the negative review class. It achieved 0.60 precision, 0.41 recall, and 0.49 F1 score. The confusion matrix showed that the model correctly identified 1006 negative reviews, but it missed 1456 negative reviews. This means the model learned useful patterns, but identifying dissatisfied customers is still challenging because negative reviews are much less common than positive reviews. To understand the model better, I used permutation feature importance. The most important feature was delivery delay in days. Other important features included number of items, late delivery indicator, number of sellers, right value, payment value, product size, seller state, item price, and product weight. This confirms that delivery performance and delivery complexity are important signals for predicting dissatisfaction. To conclude, machine learning can partially predict customer dissatisfaction using e-commerce order data. The base model was random forest with 0.89 accuracy and 0.49 F1 score for negative reviews. The strongest predictor was delivery delay, and late deliveries had a much higher negative review rate. However, the model still missed many negative reviews, mainly because the data set was imbalanced. Future work could improve this by using class balancing, threshold tuning, or more advanced boosting models. Overall, this project shows that delivery and order information can improve useful signals for predicting customer dissatisfaction. Thank you.